Hello, thank you so much for tuning into my YouTube channel. In today's video, I want to talk about handling time series data in MATLAB. The data that I have belong to 3 different offshore wind farms in which mean energy produced by them per hour over a period of 5 years have been measured. Let's get started and see how we could handle this data. As I said in this video, I want to talk about how to handle time series data in MATLAB. And this time series data is from mean energy produced by offshore wind farm. This is a problem I recently solved and I thought to make a video about it. Let's say we have mean energy produced by offshore wind farm per hour over a period of 5 years. That would leave us with a big set of data. We are trying to also extract a meaningful understanding of the data and see how the measurement is changing by time during the period of 5 years. The data in this video are measured at every hour for 5 years from 3 wind farms with the nominal capacities of 10, 12, and 15 megawatt. Let's look at the data that are saved in an XLSX file. Here is the data. This is the first wind farm with 10 megawatt capacity, and this is the second one, and this is the third one. This is the time at which the measurement is made, and this is the energy produced by that wind farm. This is the second one and third one. So as you can see, this is a big set of data. How can we use this to extract a meaningful relationship so that we see how by time the energy produced by that wind farm changes? You can see it's very big. Okay, let's see how we could handle this kind of data. So this is the first script that I wrote. First, we just have to find where the XLSX file is located. We read that into this script, and then we use read table to read in the measurements, and they're all going to be saved in this t variable, and I'm going to show you guys the whole measurements during the 5 years of these 3 wind farms. Let's run it. This is the measurement. Okay, this is the measurement. As you can see, this is the whole measurement during the 5 years of measurement, and it's very hard to tell what's going on. We can't really tell what's going on. And we can't really tell how the energy generated is changing by time. What we're gonna do is to calculate the mean energy produced per month. So each month I'm gonna calculate the mean energy produced in that month. So there are 5 years, 12 months, so I'm gonna end up with 60 measurements, which is way better than this big set of measurements. And I have no idea what's going on, how the energy produced is changing. So to do that, to calculate the mean energy produced each month, I have written this second script. Again, I read in the measurements and I save them in T. Let's show you guys the T. It's going to be very helpful. So this is the T. It's the first wind farm, second wind farm, and third wind farm. This is the time of the year that the measurement was made, and then this is the energy produced at that time. So what we do, we have to calculate the mean energy produced each month for each of these 3 wind farms separately. I start with the first one, and the second and the third one are going to be the same. The first one, I first change the timestamp, which are the date time variable in MATLAB. I change them into a string so that every one of these guys would be one string. This is one string, second, third, and it goes down like this. So I change them all into a string. And this is where I'm gonna save the mean energy produced each month, and I'm gonna count each measurement so that I know where I am. So the first one is 1, and then I'm gonna go down to these for loops. I first change each string here into character because I need to have access to a specific number of characters here, which is from 4 to 6, which specifies the month of the year in which the measurement was made. So after changing the string into character, I save the characters from 4 to 6, which is going to be the month. I save it into this variable called con, and I start summing them up, each measurement in month. I'm going to sum them with each other, and then I'm going to also be counting the number of measurements in each month so that I know how many measurements I made, so that at the end I could calculate the mean measurement per month. So I'm going to also save the first timestamp, which is going to be this one. I just need the January so that at the end I use it for plotting the month of the year against the mean measurement that I'm calculating. I'm going to be also saving up the timestamp, the first timestamp, which is going to be showing me the month of the year at which the measurement was made, and I'm going to be using them to plot them against the mean measurement I'm going to be calculating. So when I did this, I enter into this while loop. The while loop checks if it's still January, and also there is another condition. This is the total number of measurements during this 5-year period of time. So the while loop is supposed to check two things. First, are we still in the same month that we're supposed to be to calculate the mean value? And also, have we gone beyond the number of measurements or not? If we have gone beyond the number of measurements, this loop is going to be ending. The reason for this one is when you go to the last measurement, which is going to be December 2021, the month is not going to change. So if I don't change this one, it's going to be an infinite loop. So I have to also set this limit so that when we have gone through all the measurements, the while loop is going to end. So when we come here, we start adding up the measurements with each other. And we're going to count the number of measurements, and also we're going to count the number of measurements in that month. And we keep converting the timestamp into characters so that we could check if we're still in the same month. As soon as this B changes, it's going to go to the next month, which is February. And then when it goes to the next month, this while loop is going to break. When it breaks, when it comes down, it calculates the mean energy for January or in any month that it was supposed to in the while loop. And after that, that mean energy is going to be saved for that specific month. And then it's going to come back up for the second month, which is going to be February. It's going to again do the same thing. And it's going to set up the while loop. The while loop is going to go through each month like this. And mean energy per month is going to be calculated and it's going to be saved for the first wind farm. And then the second wind farm is going to be done here. It's going to be exactly the same as the first wind farm. But the thing is, when I plot the first wind farm, I'm going to also write a hold on here. And also here the same thing, hold on. Because I'm going to plot all the wind farms' mean energy produced on the same plot. Same thing here, the third wind farm. And then I'm going to plot this third wind farm, but with no hold on. Because that's the last mean energy that I'm going to plot on this plot. And I'm going to also use the legend so that I know which wind farm I am plotting. So that's about it. Let's just run and see what's going on. I'm going to again choose this. And you can see this is the mean energy produced for each wind farm, 10 megawatt, 12 and 15 megawatt. And these are the raw measurements using which we can't extract any meaningful understanding about how measurements are changing with time. So, but look at this one. This is the mean energy produced per month, and it's way better and way easier to understand what's going on. That's about it.
Thank you so much for watching this video. I hope you liked it and you were able to get something out of it. If you liked it, I would appreciate it if you could subscribe to my channel and also share the video with your friends. Thank you so much and have a nice day.